Building an AI app, it can feel like you're just wrestling with endless lines of code, right? But what if you could just design a thinking AI by, dragging and dropping a few blocks around? Well, today that's exactly what we're going to do. We're going to ditch the code editor, jump into a tool called Langflow, and build our very first AI agent completely visually.
So here's the game plan. First, we'll get a feel for what this whole visual AI building thing is all about. Then, we'll get Langflow up and running and build our first simple agent. From there, we'll level it up with a search tool, and yeah, we're going to hit a bug, it's inevitable, and we'll solve it together. And by the end, we'll have an agent that can actually think for itself. Sound good? Let's dive in.
So a lot of the time, the biggest thing stopping you from creating a custom AI isn't the idea. You've got great ideas. It's that mountain of code staring you down. But a visual approach, it completely changes the game.
I mean, if you're a developer or a creator, this question probably hits pretty close to home. You've got these awesome ideas, but then you get stuck in the weeds, right? Syntax, boilerplate code, all that stuff. And the fun part, the actual AI logic feels like it's a million miles away. The whole point here is to spend way more time building and a lot less time just coding.
Okay, so this is where Langflow comes in. Just think of it like a workbench for your AI projects. It's this low-code space where you can visually build pretty much anything, from simple prompts to these really sophisticated multi-tool agents. And the best part, it's all powered by the LangChain library, so you get all that power and flexibility, but without the massive coding headache.
All right, so before we can have some fun and start building, we gotta get Langflow up and running. The good news is it's super straightforward. There are a couple of ways to do it, really just depends on what you prefer.
So you basically got two paths you can take. If you want a super quick, one-click start, there's a desktop app. Can't get easier than that. But if you want a bit more control, you can use a command line installer like UV or pip. For this walkthrough, we're going to go with the terminal method just so you can see exactly what's happening under the hood.
Seriously, it's just 3 quick commands. First, UV init. That just gets your project started. Then, UV add Langflow, which pulls in everything it needs. And finally, Langflow run. Boom, the server is live. You just pop open your browser and you're staring at a beautiful blank canvas, totally ready to go.
Okay, now for the really fun part. We're going to build our very first agent completely from scratch. And our goal is pretty simple. We just want to create an AI that can take a request, figure out what to do, and then use a tool to solve a problem.
Okay, first things first. We grab this agent component and just drag it right onto our canvas. This thing right here, this is the brain of the whole operation. You can see it has these inputs for different parts of the system. This is the core decision maker. It's what's going to interpret our requests. And we can hook it up to pretty much any LLM we want, think OpenAI, Grok, whatever, to power its thinking.
An agent is only as smart as the tools it has, so let's give it one. We'll just search for the calculator component, there it is, and drag it out. Now, see this little tool mode switch? This is super important. Flipping this on is the key. It basically turns a simple function into something our agent can actually recognize and decide to use. We just wire it up to the agent's tool input, and just like that, our agent can now do math.
All right, let's put it to the test. And we're not going to go easy on it with a simple sum. No, we're giving it a multi-step problem that actually requires some reasoning. First add this, then multiply the result, then divide that. This is going to force the agent to decide if it should use the tool we gave it and how.
And the answer is 50! It got it right! But hold on, how do we know it actually used the tool and didn't just guess? Well, this is the cool part. We can expand the agent's log, and we can see the entire trace. It shows right here that it got our request, it knew it was a math problem, and it called the calculator to get the job done. That's our first win.
Okay, that was an awesome start. But right now, our agent is kind of living in a box. It has no idea what's going on in the real world. So let's fix that. Let's give it a window to the internet.
Time for a much more complex challenge. We need our agent to answer a question that needs 2 things: real-time info from the web and the ability to do math. Something like, go find the current price of Apple stock and then tell me how much it would cost to buy 50 shares. This is going to require 2 different tools.
So to give our agent this new superpower, we're going to add the Tavily Search API tool, and it's the exact same process as the calculator. We drag it out, flip on that tool mode switch, and plug it right into our agent. So now our agent has 2 superpowers. It can do math, and it can search the web.
Look, in any kind of building process, things rarely work perfectly on the first try, and that is totally okay. Hitting the bug isn't a failure. It's actually a super important part of the journey. So let's see what happens when we try to run our new, more complex query.
And yep, there it is, an error, a JSON parse error to be exact. The agent tries to do its thing, but it just gets completely stuck. And if you look at the logs, you can see the LLM even tries to answer on its own without the tool, but it gets the stock price totally wrong because it's just guessing from its training data. This is such a classic developer moment, right? But the great thing about Langflow is that it helps us see exactly where that breakdown happened.
So, what went wrong? Why did it fail? Well, it turns out that Tavily tool was sending back data in this complex format that our agent just couldn't understand. It was basically like trying to read a language it doesn't speak. But the solution? It's actually really simple. We just swap it out for a different component called web search. This new tool sends back plain, simple text, a format our agent can easily read and work with. And this is a perfect example of how this visual way of working helps you find the problem fast and just swap in the right part.
Okay, the bug is squashed. Our agent now has 2 tools that actually work. It is time for the final test. Can this thing we just built actually reason, make a plan, and then execute a multi-step task?
So we ask it the exact same question again, but this time, our agent is ready for it. It has a working web search tool, and it has a calculator. Let's see what it does.
And this is where the magic really happens. When we look at the logs, we can see its exact thought process laid out. First, it thinks, I need information. So it uses the web search tool. It finds the Apple stock price is $248.04. Then it thinks, okay, now I need to do some math with that number. So it calls the calculator tool, multiplies that price by 50, and gets the final result. It reasoned, it planned, and it executed perfectly. It worked.
So there you have it. In just a few minutes, without writing all that crazy code, we went from a totally blank canvas to a working AI agent that can grab real-time data, use tools, and solve problems with multiple steps. We've really seen firsthand how a visual platform like Langflow opens up AI development to so many more people. So the only real question left is, what are you going to build next?